Online learning is a type of machine learning where the model learns incrementally from a stream of data. Unlike traditional batch learning, online learning algorithms process data points one at a time or in small groups. This allows online learning models to adapt to changing data patterns over time. They are dynamic and constantly evolving. Imagine you have a weather forecasting model. With batch learning, you would train the model on historical weather data and then use it to make predictions. However, weather patterns can change over time. Online learning allows the model to continuously update its predictions as new weather data becomes available. Online learning is especially valuable in situations where data is generated in real time, such as stock prices, social media trends, or sensor data. It's also useful when dealing with massive data sets that are too large to fit into memory for batch processing. Building an online learning model involves a continuous cycle of prediction, feedback, and update. Here's a step-by-step breakdown of the process. First, initialization. Start by initializing the model with an initial set of parameters. This could be random or based on some prior knowledge. Next, prediction. Receive a new data point and use the current model to make a prediction. Then, loss calculation. Compare the model's prediction to the actual value and calculate the error, often referred to as the loss. After that, parameter update. Adjust the model's parameters based on the calculated loss. This step is crucial for the model to learn from its mistakes. The magnitude of the adjustment is controlled by a parameter called the learning rate. Finally, repeat. Repeat steps 2 to 4 for each incoming data point or mini-batch, continuously refining the model's predictions. This iterative process allows online learning models to adapt to new information and improve their accuracy over time. The learning rate is a critical parameter that determines how quickly the model adapts to new data. A high learning rate might lead to rapid initial learning, but could also make the model unstable. Conversely, a low learning rate might result in slower convergence, but can lead to a more stable model in the long run. Online learning models have the unique ability to dynamically select and adapt algorithms based on changing data. This intelligence comes from continuous monitoring and evaluation of data patterns. Some of the most commonly used online learning models include linear models. These models, such as stochastic gradient descent, are computationally efficient and work well for linearly separable data. They are often used in applications like online advertising and recommendation systems. Support vector machines, or SVMs. SVMs are powerful models known for their ability to handle high-dimensional data. Online variants of SVMs like Pegasos make them suitable for large-scale online learning tasks. Ensemble methods. Techniques like online bagging and boosting combine multiple models to improve prediction accuracy. They are particularly useful when dealing with complex data patterns. The choice of the best model depends on the specific problem, the nature of the data, and the desired trade-off between accuracy and computational efficiency. This dynamic selection is driven by the model's ability to learn and adapt in real time. While online learning offers significant advantages, it also comes with its own set of challenges and limitations. Concept drift. One of the main challenges is dealing with concept drift, where the underlying data distribution changes over time. If not handled properly, the model's performance can degrade as it clings to outdated patterns. Catastrophic forgetting. Online learning models can sometimes forget previously learned information when exposed to new data, especially if the new data is significantly different. Parameter tuning. Finding the optimal learning rate and other hyperparameters can be tricky, and often involves a trial and error process. Addressing these challenges often involves techniques like adaptive learning rates, concept drift detection mechanisms, and ensemble methods to maintain model robustness in dynamic environments. Python, with its rich ecosystem of machine learning libraries like scikit-learn and TensorFlow, is a popular choice for implementing online learning algorithms. R is also used, particularly in statistical learning and data analysis. Building expertise in online learning requires a solid understanding of machine learning fundamentals, optimization algorithms, and the ability to analyze and adapt to dynamic data streams.